the membrane itself here is not permeable to hydrogen ions. The only way that hydrogen ions can osmose through to the other side is through this complex, which is called the ATP synthase. This is an amazing molecule, and you're going to be reading more about this molecule in your recitation sections. It's just amazing. I'll say no more. But the idea here is that this uses the gradient here of hydrogen ions to make a motor that rotates. This is like the smallest nanotechnology you can think of. This is the molecular motor that rotates this thing and causes this enzyme to work some mysterious and wonderful fashion. So there are these four complexes here, as we saw before. And here's the motor. So the hydrogen ions come down here. They're caught through this little channel here. And this is actually a turning it's called a rotor, but it's a bunch of proteins that are put together. It's a multi-protein complex. It turns, and after a single rotation of this complex, that pushes that hydrogen ion out and into the matrix of the diamond. So turning this rotor makes this shaft rotate, and what that does is it changes the conformation of these subunits here, which are basically ATPases, or ADP phosphorylases. So this causes this enzyme to change its conformation such that ADP can now be phosphorylated to make ATP. Isn't that awesome? That's amazing. One of those, things in biology that just make you awesome. And how the scientists actually figured out that this thing is turning, and that the concentration gradient is totally sufficient for that to occur. It's really great, and that's what you're going to be reading. All right, so this brings up some hypothetical kind of exam-like questions that professors like to ask you on your exam. So suppose that we did this to the system and changed it somehow. What would happen if you understand this process like we hope you do? Suppose we introduce pores into the membrane, which allow protons to pass through. How would the pH or the intermembrane space change? So the intermembrane space being up there, because outer membrane is on top of that. So if we introduce pores, what's going to happen? Speak up, please. I'm already hard of hearing. Sorry? The pH will go down where? Hydrogen ion concentration will go down, which means that the pH will go up. Okay? I know the pH is really confusing. So that's right. So you make pores in here, and then what's going to happen to the gradient? It'll equilibrate, right? So you won't have a gradient anymore. If you don't have a gradient to drive the ATP synthase, what's going to happen? No ATP, right?
But it doesn't need the gradient to drive it.
I'm sorry?
It doesn't need the gradient to operate.
Oh, yes. Oh, that's what's driving this whole rotating shaft.
Yeah, but it can also go backwards against the gradient. So it doesn't need the gradient. That's it.
It doesn't go backwards all by itself. This thing can go backwards, absolutely right. But that would mean you need the gradient in the opposite direction. So you would still need a gradient. But if you punch holes in the membrane, really what you're doing is you're getting rid of the gradient.
But what is the H ions enter the binding sites on what we call the C subunits.
That's right. So the ions, the protons are actually pushing the rotor.
They can also attach coming in the other direction. Wouldn't that'll still happen with or without gradient, right? still
So think of like a mill.
It's just that.
Think of a grist mill, like in the, the early 1700s, 1800s here in New England. Maybe you've seen them. They have these water wheels, and there's a gradient of water. So it's a gravity gradient in this case, but the water is actually turning the wheels, right? And if the stream is such that maybe it's flooded or something up this way, then the wheel will stop turning, even though there's water there. So yes, ions are maybe in there, but because there's no gradient, the wheel stops turning.
Why is this gradient turning? I know when it enters the binding site, it changes the conformation for the road.
So it's chemical osmosis, which is driving this whole motor, right? So it's because there are protons on this side and not protons on this side, and causes these protons to go through. And that's what turns the motor. We can talk more about it later, but I want to get to the think of the gradient as being extremely important for making this whole process work. And if you don't have the gradient, you don't get ATP. Now let's think about it a little bit further. How would this affect metabolism upstream? In terms of glucose, the consumption of glucose. If you're not making ATP, what's happening upstream? I'm sorry?
It needs to increase in order to compensate.
So that's right. So in your body, this is one of those important aspects of life. There are these homeostatic mechanisms, right? So there's regulation. And specifically, there's this thing that's called feedback regulation. We talked about this when we were talking about glycolysis. There's a step in glycolysis where regulation occurs. It's really important. Phosphofructokinase is the name of the enzyme. And what happens to how is that enzyme regulated? Exactly right. So if you have ATP, if you have a lot of ATP around, that enzyme will be inhibited, glycolysis will be shut down. So now if you have ANP, so this is what that's going to turn into if you don't have